Now we define the average velocity and instantaneous velocity graphically. What they graphically represent. So we draw the graph, position time graph. This is time, this is position, and this is the reference point. Similarly, one more graph is taken, position of time, position and origin. Time is taken in seconds, position is taken in meters. Now suppose graph is this, position time graph is this, and we have to find the average velocity between time t1 and say t2. And similarly, we have to find the instantaneous velocity at this time, say t3. So to find the average velocity, we have said that average velocity is net displacement by time taken. So from graph, time taken is this, that is the t2 minus t1. And net displacement is, if we have to find net displacement, and this is, initially it was at x1 and then it is x2. So net displacement is x2 minus x1. Hence, average velocity is x2 minus x1 oblique t2 minus t1. We can say this is the slope of chord. Which chord? If we say this is a point A, this is the point B, so this is the chord AB. That means chord of the slope of the chord gives the average velocity. Similarly, if I have to find the instantaneous velocity, in that case, mathematically we have already discussed that instantaneous velocity is limiting case of average velocity, where we take delta t tends to 0 and delta x by delta t, that is equal to dx by dt. We have mentioned in this way. Graphically, what it means? It means that we draw a tangent at this point and find the slope of this tangent. So this is t1, this is t2, and this is say x1, and this is x2. So delta x by delta t, that is the x2 minus x1 divided by t2 minus t1. And we take this limiting case of delta t tends to 0. That means we bring this t1 and t3 so close that it becomes at that particular instant. In that case, we take very small height along the x-axis and a small length along time axis. This elementary small parts ratio gives us the instantaneous velocity, that is velocity at a particular instant. So we can say in this way that instantaneous velocity is the slope of tangent at the point at which we have to find the velocity. So it is to be memorized that average velocity is the slope of chord and instantaneous velocity is the slope of tangent. Next we take velocity time graph.